A few weeks ago, we told you about a threat made by two former governors who said they would sue the federal government if it shipped commercial spent nuclear rods to Idaho for research. We heard from former governors Cecil Andrus and Phil Batt, who are against the plan because they feel it goes against the spirit of the 1995 settlement agreement, which prohibits commercial spent fuel from being shipped to Idaho. We also heard from Governor Otter and Attorney General Lawrence Wasden, who say this small allowance forces the Department of Energy to speed up the construction of the Integrated Waste Treatment Unit, which is behind schedule. Missing from our recent stories is perspective from the lab itself. Recently, Aaron Kunz visited the Idaho National Laboratory to see the progress of the cleanup project and see how the INL uses these rods as part of its nuclear research mission.
The 1995 BAT settlement agreement.
The state managed to negotiate the 1995 settlement agreement under Governor Phil Batt. That agreement has several milestones or benchmarks and requires the Department of Energy to remove all high-level buried waste by 2035. Has the department met those benchmarks? Well, yes and no. Meet Jack Zimmerman, Deputy Manager of the Idaho Cleanup Project.
Overall, the cleanup project in Idaho is ahead of schedule and associated with agreements in most every area. There's been over 500 specific regulatory milestones that were associated with various agreements with the state of Idaho that have been met already. Only a handful, approximately 10, were actually missed or late. For example, in this area right here, we're about 3 years. We should finish about 3 years ahead of schedule. We're projecting 2020 completion as opposed to a 2023 milestone. Also, over at the Advanced Mixed Waste Treatment Plant, we are right on schedule to retrieve, certify all that waste. We do have a slight hiccup in that the waste isolation pilot plant is not accepting waste right now because of an accident that they experienced about a year ago. But we expect to resume shipping in the 2016 timeframe. The only other area where we've experienced a significant delay is with the Integrated Waste Treatment Unit. And that involves processing the last liquid high-level waste from 3 tanks that we have on site here. 11 out of 15 tanks are already closed with the high-level waste process turned into a solid and it's stored safely.
The INL has 2 major missions, the cleanup project under management by the Department of Energy and the research and development mission under the Idaho National Laboratory. Jack Zimmerman with the Department of Energy took us to the Radioactive Waste Management Complex to see recent progress. It's an area filled with massive white tents covering the place where radioactive waste was buried underground between the 1950s and the late 1960s. The mission is to recover that waste and package it for shipment to a site in New Mexico.
This is number 8 out of 9. This area is received waste from the Rocky Flats plant that was located in Colorado. The purpose of the Rocky Flats plant was to manufacture components for nuclear weapons. A lot of those components is a manufacturing process that would contaminate clothing, tools, some oil sludges or grinding sludges, and those wastes were shipped to Idaho, where up until 1970 they were buried. And this is the area where that waste was buried up until 1970. So these are, right now, we're just in the process of excavating these. The facility that you're standing in is built for the sole purpose of covering, it covers the ground for the targeted waste. And we are retrieving those, so this contains the release, protects the environment from any airborne release, as well as provides a safer environment for the workers. Basically, you're looking at drums that were buried many decades ago underground, exposed to the elements. Most of the drums have decayed to the point where there's not much left of it. So we're actually pulling that material out of the ground. And we have a drum pack processing station where we have material handlers as well as visual examiners that look to make sure that all the items are acceptable for disposal at the waste isolation pilot plant. Those are sorted, segregated, goes through a characterization process, and that makes sure that we can safely dispose of this material at the waste isolation pilot plant. Okay, these are called TruePack 2s. These are NRC licensed transport casks for the transuranic waste. This is how we ship the waste from Idaho to the waste isolation pilot plant in New Mexico, is we would load these transport casks. These are engineered, designed, tested, and licensed to withstand any feasible accident that might happen while in transport. We continue to retrieve, certify, and package this waste for disposition at the waste isolation pilot plant when it resumes operations. We currently have over 570 certified shipments ready to go, and our goal is to have this material ready, and we'll be waiting on the WIP reopening.
The waste isolation pilot plant in New Mexico is currently closed after a fire back in 2014. Most of this waste will be shipped by truck to that facility once it reopens. But for now, the packaged waste is stored in hundreds of barrels ready to be shipped.
Right here, we're in the facility, the overall complex, the Advanced Mixed Waste Treatment Project. This facility is the radiological enclosure that was built over where the waste from Rocky Flats was shipped and had been originally stored on these asphalt pads. So if you had been in here at the start of the project, this area where we're standing would have been filled full of drums of Rocky Flats waste stacked up about halfway to the ceiling. Behind me, the black drums are drums that were treated here at the Advanced Mixed Waste Treatment Facility, and those drums are awaiting shipment to the waste isolation pilot plant. We have over 500 regulatory commitments that have been met since the inception of the project. Only about 10 commitments have not been met. Several of those are related to the Integrated Waste Treatment Unit. As far as the Integrated Waste Treatment Unit, that is a new technology that the department has spent a considerable amount of money developing and deploying because there wasn't not a viable treatment for this high-level waste. So we've created a new process. There's a lot of technical challenges associated with deploying new technology, one of a kind, first time. So we have recently negotiated a consent order with the state of Idaho, and we've submitted a draft compliance schedule that would establish new milestones for completing that project. So we anticipate we will start up that project no later than September of 2016 as far as processing real waste, and completing all of that, the processing, no later than December of 2018.
The Integrated Waste Treatment Unit is the facility that must be up and running before Governor Otter and Attorney General Lawrence Wasden will allow 2 small shipments of commercial spent nuclear fuel rods to enter the state. Those rods would end up here at the Materials and Fuel Complex. That's where we met up with Todd Allen, the Deputy Director for Science and Technology at the lab.
So in a nuclear reactor, right, the way we make electricity is we use nuclear fission. We create heat boils water, water turns a turbine, and it makes electricity. Okay? The way that the heat is generated is if a uranium atom captures 1 neutron, it will separate into 2 small pieces we call fission products and some more neutrons, typically 2 to 3 per fission. The way a reactor works is we want to get one of those neutrons to come back and cause another fission so that it keeps making heat at steady state. But each fuel is not the same, right? So depending on the material that the fuel is made out of and the specific conditions of that reactor, you'll get different kinds of changes. And so the facilities here allow us to study those changes. But what's important when we talk about the 50 fuel rods that have been proposed to come here is that we want to study problems that are very specific to high burnup, meaning long life, light water reactor fuel. Right? And in order for us to study those, we need the right material irradiated in the right conditions so that we get the right kind of changes. We just can't arbitrarily look at a different type of fuel and understand what's happening in the light water reactor. So to give you an idea of what we mean by a fuel rod, right? This is, it's a mock-up, but it's half of a fuel rod. So the diameter is correct, but it would be twice as tall. Okay, so there'd be 50 of these. In a typical reactor, the fuel is bundled in assemblies like this, and each assembly has 264 of these. So what's being proposed to be shipped here is a fraction of 1 assembly. Now within the reactor you've got hundreds of assemblies. And of course within the nation you've got about 100 reactors. From a research standpoint, these are high value, right? And I don't even like to call them spent fuel, I like to call them light water reactor fuel because to me it's high value because we can only answer specific technical questions that the country needs to answer. But there's not a lot of it.
Allen says there are unique differences in fuel rods at each nuclear reactor. Similar to snowflakes, each is different, and it's important to know what those differences are before it can be safely stored. So the commercial reactors would send a small fraction of the rods to Idaho, where scientists will run all types of experiments on them. They are shipped in a container like this one, a large steel cask that looks ominous, but Allen says it's mostly safety features.
It is mostly safety. It's designed, right, so that under any accident condition, the fuel inside, the radioactive material, is not going to leave the container.
Once the spent fuel arrives, it's removed from the container and stored in an underground vault under this building.
So it will come to the facility in a big shielded cask. Okay? And then we have equipment that allows us to take the cask, still closed, go underground underneath this hot cell, which we're going to show you. And these are 4-foot thick concrete walls, 4-foot thick leaded glass windows. You'll notice that we don't need any specific radiation protection where we're standing, even though on the other side of that wall there's a significant amount of highly radioactive material. So it's never unshielded, right? And it's always on the other side of a significant amount of radiation shielding.
The rods are cut into small pellets and subjected to heat and stress, viewed through special microscopes and tested by scientists using robotic hands through 4-foot thick walls to handle the material.
This really is the place because of the complete end-to-end capability. There are other places in the country that can do portions of this work. If we're going to be the Idaho National Laboratory, then we need to be able to look at these types of research issues. And if we can't, it'll drift to some other place in the country because they're questions that need to be answered.